Hello, smart mathematicians. Let's continue with our lesson on the counting principle. We're going to look at rule 4. In general, the number of different ways that n letters can be arranged, treating all repeated letters as the same or identical, where a of the letters are identical, B are identical, C are identical, and so on. Then we can say that the number of different ways is equal to n factorial divided by a factorial times b factorial times c factorial and so on. Okay, so this may be confusing, but let's look at an example. Let's look at an example. Right. If you look at the word proceed, how many letters do we have? We have 1, 2, 3, 4, 5, 6, 7. So we have 7 letters. So it said in general, the number of different ways that n letters, so in this case, 7 letters can be arranged. And then treating repeated letters as identical. So now, which letters are being repeated here? It is these letters, the E's. You see that? So we're going to treat them as what? As identical. And then what we do? We say that the number of different ways is going to be n factorial. Looking at our example, our n is 7 divided by a factorial, because now we have where a of the letters are identical. So we have 2 letters that are identical there. So it means it's going to be 2 factorial. So now you look at the repeated letters. So we're going to have how many? 1, 2, 3, 4, 5, 6, 7, which is going to be 7 factorial. And then look at the repeated letters. There are 2 divided by 2 factorial. We don't have any other repeated letter. You see that? So now let's look at the question. How many word arrangements can be made if the repeated letters are treated as identical? And then how many word arrangements can be made with the letters of this word if the word starts and ends with the same letter? Okay, let's do question A first. So question A, the word arrangement is going to be 7 factorial divided by 2 factorial. We have 1, 2, 3, 4, 5, 6, 7 letters, and then we have 2 letters being repeated here. So that's why I say 7 factorial divided by 2 factorial. So it means we have 2,520 ways. Right, let's get question B. How many word arrangements can be made with the letters of this word if the word starts and ends with the same letter? So it means now it should be starting with E and ending with E. Okay, so it means these 2 letters are going to be fixed, one at the beginning and the other one at the end. So we have 5 factorial. Okay, why 5 factorial? E's are fixed and we are left with P, R, O, C, and D to create different word arrangements. So it means we have 7 positions, isn't it? We have 7 positions. The first position, second, third, fourth, fifth, sixth, seventh. The first position is going to be fixed because it's just what E here. So it's 1 here. And then the last position again must be E is 1 here. And then these ones can be arranged in different ways. And then how many letters do we have? 1, 2, 3, 4, 5. So we have 5 factorial ways. So it's going to be 1 times 5 factorial times 1, which is just 5 factorial. And then we have 120 ways like that. Okay, right. And then let's look at this one. Consider the word selections. How many word arrangements can be made if the repeated letters are treated as identical? How many word arrangements can be made with the letters of this word if the word starts with E and ends with E? And then how many word arrangements can be made with the letters of this word if the word starts and ends with the same letter? Right, let's look at question A first. So now we have how many letters altogether? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, but we have these letters repeating. This one E, this one here, and then the S there, the S there. So how do you find the different ways? We say 10 factorial divided by 2 factorial times 2 factorial, because E is repeated S is repeated. You see that? And then we have 907,200 ways or arrangements. Okay? Right, let's look at B. How many word arrangements can be made with the letters of this word if the word starts with E and ends with E? So it means the E's are fixed. Okay, the E's are fixed. So we have how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, the first one is fixed, must be in E, so it's one choice. The last one must be fixed, it's in E, it's one choice. And then we have these 8 letters that can be arranged anyhow, which is going to be 8 factorial. Right, but if you check at these letters that can be arranged anyhow, we have S and S. So S is repeated here. So it's going to be 8 factorial over 2 factorial. Okay, because we have the E's are fixed, yes, but the S's are there and they are repeated. They're treated as identical. So it's going to be 8 factorial over 2 factorial. And then we get 20,160. Okay, right. And then let's look at C. How many word arrangements can be made with the letters of this word if the word starts and ends with the same letter? So we have two situations here. It's either starting with E and ending with E, or starting with S and ending with S. Now it's or E or SS. So it's going to be, we're going to find the two different ways and then we add them. So E's or S's are what? Are fixed. So it means when E's are fixed, we have it's going to be 8 factorial over 2 factorial, just like what we did in question B. And then same thing when the S is what? Is fixed. So we're going to have what? It means this one is not it's just one there, and then we're remaining with this. And then the E's are what? Are repeated. So it's going to be again 8 factorial over 2 factorial. And then what we do? We add these two. Weight arrangement is going to be 20,160 plus 20,160, which is 40,320. Okay, so this is how we treat repetitions and we use our rule number 4. Okay.